All right, so for 8.2 today, okay, we are going to look at vertex form of a quadratic, okay? Okay, we are looking at vertex form of a quadratic. So vertex form of a quadratic is y is equal to a times parentheses x minus h squared plus k.
How did we get the h?
That's placeholders. You know how in a squared plus ax squared plus bx plus c, it has a, b, and c as placeholders? That's what this has it as placeholders. Okay? And we have actually seen something very, very similar to that when we looked at transformations. Okay? We have seen stuff very similar to this. So when we look at this, we are actually able to just immediately identify our vertex and our axis of symmetry. So our vertex is just going to be the point H and K. And that's our vertex. Okay, and our axis of symmetry is the point X equals H. Yes?
Why you couldn't just do y and x?
Because X and Y in that equation are like your variables. So H and K are placeholders in the equation for, you know how in standard form we have negative b over 2a to find our x? Okay, the same thing is happening here except it's in a different form. It's already made to give us that. So just like how we had to find that in standard form, we're having to find it now. It's just we won't have to do any calculations to find it. So if y'all remember, we're going to quickly recap when we have seen something similar to this form, okay? So if we had the equation y is equal to x minus 3 squared, where is the change happening, inside or outside of the function?
Outside. Inside.
It's inside the parentheses, right? It's inside of the square, so it's happening inside the function, okay? And so when it happens inside the function, that minus 3 is going to cause a horizontal shift. When it's negative 3, which way does it shift it?
To the right.
To the right. Because remember, what number would I need to put right here so that this equals 0? 3. Positive 3. So that moves it to the right 3. Yes, ma'am? Go ahead. Okay, now, what if we have y is equal to x plus 3 squared? Which way is that going to cause it to move? Left.
And you're going to go up, you're going to go down with the y.
Okay, now, whenever we move the x, so it's going left or right, we're moving the x coordinate of our vertex. That is going to move our vertex to the right 3. So if we start at 0, 0, and we move our vertex to the right 3, how would that change the point?
It'll move to the right too.
So what would the new point be?
3.
3, 0. Okay, for left 3, where would that move the new point to?
Negative 3.
Negative 3, 0. Now we're going to look at what happens when it's outside the function. So if we have y is equal to x squared, and then we do plus 5. When it is outside the function, that's where we have a vertical change. So is plus 5 on the outside going to make it go up or down? Up. And how would that affect the vertex? Is that going to affect the x or the y? So it'll be 0, 5. Okay, what if we do y is equal to x squared minus 5? What is that going to cause to happen?
Go down.
It's going to cause it to go down. So what will the vertex be? 0, negative 5. So the way that those two numbers, whether it's inside or outside, affect our graph is affects where our vertex is. And just by seeing those transformations, we can know where our vertex is. So for number 1, We have an inside transformation. What is the inside transformation?
It's going to the right,
Right
to the
forward.
left forward.
Left 4. Yep, that one goes to
Down
the
2.
left 4. And then it goes down 2.
Let's go. This is easy.
Okay, so where is that vertex going to be at? What was that? -4, -2. Okay, so we should write that as -4, -2. Now, axis of symmetry is just whatever the x coordinate of our vertex is. So it's x equals -4. So by looking at just those 2 transformations, we can find the vertex. So for number 2, what is the transformation happening inside the function?
Right 3.
Right 3. Is there anything being added or subtracted outside? Oh, no, right? So what is my vertex going to be?
Nothing.
3.
Stay on
Okay,
X.
which direction did we say -3 made it move?
I know, positive 3.
Right. Okay, so because of that, it's going to go to 3, comma,
Yeah.
0, because nothing was outside for it to add to. And so what is our axis of symmetry?
3.
All right, let's go ahead and look at number 3. What is the inside transformation? What's going to move our x?
To the right 5.
To the right 5
Down 4.
and down 4. So what is our vertex going to be?
5, -4.
And what's our axis of symmetry?
5.
Here we go.
Ms. Dobson,
Yes.
will it always, for the number that's in the parentheses, will always just be the opposite when it goes to being the vertex?
All right, now for number 4. And the reason for that is because in order to make the whole parentheses equal 0, you would need to put a +5 right there, which is why it moves it to the right. All right, for this one, is there anything inside the function for this one?
No.
No, because the x doesn't have a parentheses in it. It's just hanging out there. So what does that mean my x coordinate is going to be? 0. Okay. And then what's the outside transformation happening? Up 3. So what does that need to be?
0.
And what is our axis of symmetry?
Here we go.
All right, now we're going to look at graphing these. Okay. So we're going to find our axis of symmetry and vertex, just like we did on those 4. And then we're going to graph like how we have last week. So for number 5,
-2.
what was that?
-2.
-2, 7, because we have a +2 and a 7. So that's going to go to -2, comma 7. And x equals -2 is our axis of symmetry. Now, we just plug this into the middle of our table. So we get -2, 7. And then we use our calculator. So everybody should have a graphing calculator. And when we look at this, we're going to go to y equals again. Clear out anything that's there, and we will do, what is our equation? Negative parentheses, x plus 2
Squared.
squared
Plus 7.
plus 7. And then, what's the buttons I pressed to show the table again?
Y equal, no, yeah.
Yep. And then we just fill in using our table.
Look at that. Wait, how do I get to see the table?
Y, or second graph.
Oh, look at that. Yeah.
And then once you get all of your points, plot them on the graph. Yes.
Why is mine giving me all these like 4 numbers?
Let me look.
It's like 400,000.
Because someone thought they could figure out how far the calculator could calculate by clicking it. So what you're going to do is you are going to click second plus 1, Or
712.
7,
712.
second plus 712. That is much easier than going all the way back down to 0. And then just regraph it and you should be good. All right. Also, everyone in here listen up, okay? If you are one of the people that have been messing with the calculator, seeing how far up or down you could go, stop, okay? It's A, making it difficult on your classmates if they grab that calculator, and B, doing it too far too fast can cause the calculator's programs to crash because you're making it calculate numbers in the billions. Okay? So stop doing it. Does everybody understand? I'm going to go through and reset all of the calculators after school, but we've got to stop doing that. All right, now we have this as our graph. So does this graph ever stop going to the left? Does it ever stop going to the right?
No.
So our domain is? All right, does this graph ever stop going down? And then does it ever stop going up?
Yes.
Where? So we go from negative infinity to 7. And that is how we would do this problem.
You put a bracket behind the sun.
Yes, sir. All right, now
There go.
we're going to look at number 6. Actually, yeah, we'll do number 6. Okay, for number 6. Okay, what transformation do we have that affects the x coordinate?
Right one.
Right 1. So that makes the x coordinate what?
1, 0.
And it is going to be 1. And then is there anything that affects the y coordinate?
No.
So it will just be 0. And we put that in the middle of our table. Then we should plug in stuff on both sides using your calculator. So y'all go ahead and do that. Plug in that equation into your calculator. So once we get those table values, does this calculator go all the way up to y equals 12? Or not the calculator, this graph go all the way up to y equals 12? No. So plot the points you can plot on the graph and then draw it to the best of your ability. So we would do 0, 3, 1, 0, 2, 3. And that is roughly what the graph would look like. Because the next point would be up here somewhere. Now, does that graph, what's its domain? Negative infinity to positive infinity. What's the bottom of that graph?
0.
What's the top? Infinity. So that is how we will do that. Okay, so we talked about our transformations, okay? So next we're gonna actually define transformation and talk about what that means. So I want us to look at the top of the back of this page. The most simplistic quadratic equation is the equation y is equal to x squared. This has no transformations. Nothing is changing to make it get skinnier or wider. Nothing is changing it. It is the most base form. That is called the parent function. The parent function is just as plain as it can get function of a family of functions. And it's the one that all others are based off of and come from. So we can take that one x squared and we can change it to make it any quadratic we want using transformations. So a transformation is a change to the size or location of the figure. So we've already been talking about these, okay? All this part wants us to do is kind of formalize it a little bit more. So for number 7, actually, let's do number 9. Okay, number 9. What transformations does number 9 have?
To the right one, brought down
Okay.
6.
So that one goes to the left 1. And then we said what else it had?
Down 6.
Down 6. And that is how we write out the transformations. Okay. If it says list your transformations, you have to say left 1, right 6. Now, what would that make our vertex? Now use the table to do the rest of it. And then once you get the table from your calculator, graph it. So the reason they ask you to draw this on the graph with that one that's already there, that is the graph of x squared. Okay, and all that does is it shows you very clearly how it's the same graph, it's just the same graph that's been moved left 1, down 6. Because it just moves the vertex of it from here, left 1, then down 6. And that's how it gets there. Now, we're going to also look at number 10. So for number 10, does anybody remember what putting a negative at the very front causes to happen to a graph? It flips it upside down. And how we need to say that is it's going to reflect across the x-axis. What else is happening as far as transformations go? To the right 4. What else? Up 1. So what would our vertex be? 4, 1. And we can put that in our calculator and get our points. Once you get your table, plot the points. Okay, and what happens here is it causes it to flip over the x-axis. And then it's going to move to the right 1, 2, 3, 4. Then it's going to move up 1. So it's the same graph, it's just being moved. Now we're going to go to the next page. Okay, we're going to jump down to the put it together part. So given a quadratic equation in the vertex form, y equals a times x minus h squared plus k. H is the horizontal shift. A plus shifts it to the,
Left.
a minus shifts it to the, K is the vertical shift. Plus shifts it up. Negative shifts it down. If A, so the number in front is negative, what happens to it? It reflects across which axis? So it reflects across the X axis. Now, if A is 1, okay, that makes a vertical stretch. Basically what that does is it makes it get taller faster. It's like taking your height and multiplying it by 2. What happens to you when you do that?
I get very tall.
You get very tall, right? So it's causing it to happen quicker. And it's going to make our graph end up getting skinnier and pulling it up. It's like if we take the graph and just go whoop, with it that way. Now, if A is between 0 and 1, okay, that is a vertical compression. What would happen if I took your height and multiplied it by 1/2? You get half as tall, right? Basically what that does is it makes you get taller slower. So like instead of pulling it, stretching it this way, you're going to pull it and stretch it, push it down together. And is that going to make it get skinnier, or is that going to make it get wider as it gets pushed down? Wider. Okay, so whenever you have A between 0 and 1, your graph is going to end up being wider. Whereas when it's skinnier, or when it's above 1, it's going to end up being closer together. Because you're literally, it's the difference between taking it and pulling it this way or smushing it this way. And that can also be upside down if it needs to be, because A flips it negative. All right, now we're going to write the equations from the transformations. So for here, okay, is that going to be an inside or outside of the function? Inside. So we will say y is equal to parentheses x squared, but what needs to go inside the function? Minus 2. For 14, does that need to happen inside or outside of the function? So we will do y is equal to x squared. What was that? Plus 5. Number 15? Yes. Go ahead. This one has 2 transformations. It has one inside and one outside. So to do this one, we do not f of x. We do y is equal to x squared. What needs to go inside the function? What needs to go outside? For number 16, what are the transformations happening? And 4 up. So we have one inside and outside. So we do y is equal to x. What needs to go inside? Outside? For number, yes, when George gets back. For number 17, okay, this one has reflected across the x-axis. What does that tell me needs to happen? Let's put a negative in the very front. And then it says it needs to go 3 units down. Is that an inside or outside part of the function? So we do x squared, then what? Minus 3. So again, we have a reflected over the x-axis. So what do we have to put? A negative in front. But then we have an inside and an outside transformation. What is the inside transformation? And then we have, whoops, 2 units down. So we will do parentheses x minus 5 squared minus 2. For number 19. It is being vertically compressed by a factor of 1/3. So I have to put a 1/3 in the front. And then it gets translated 8 units up. So does that part need to be inside or outside? Outside. So we'll do x squared plus 8. And then for 20, I'm going to let y'all read it. And y'all are going to tell me what needs to go where. So it'll be y equals what? What was that? Y equals what?
2.
2, because of what?
Specify.
What else do we need though? I have a question. Right here it says reflected over the x-axis. So what does that mean needs to go in the very, very front? And then we do the parentheses x. So what needs to go inside the parentheses? Plus 4. So for these, they really are easier than when they are in standard form. You do not have to calculate where the vertex is. The problem gives it to you as long as you remember your transformations. So we have a couple minutes left. So why don't y'all start working on the next page in the pink packet?